Our first speaker today is Dr. Mitra Mirhassani. Mitra is an associate professor in the Electrical and Computer Engineering Department at the University of Windsor. Her research interests include hardware security, Trojan detection, and quantum-safe encryption. She and her team are investigating a range of hardware security issues, such as detecting malicious Trojan hardware, efficient implementation of post-quantum algorithms, and implementation of public unclonable functions. She's a senior member of IEEE and serves as the associate editor for IEEE Access Journal and guest associate editor of IEEE Transaction on Computer-Aided Design. She's the advisor to the Women in Cybersecurity Windsor chapter and was recognized as one of the top women in cybersecurity by IT World Canada in 2020 and won the 2020 Outstanding Achievement Award from the AMPA Cybersecurity Initiative. Congratulations, Mitra. She's also the co-founder and the co-director of the SHIELD, the Automotive Cybersecurity Center of Excellence at the University of Windsor. Please join me in welcoming Dr. Mitra Mirhassani, joining us today from Windsor, Ontario.
Hi, everyone, and thank you for having me on the CANARIE Summit. I'm very excited to talk about hardware. But before moving on, I just wanted to provide you with a little bit of information about our center and what we are doing, because the range of activities that we are doing at the SHIELD Automotive Cyber Security Center of Excellence is actually much more widespread than my actual talk and presentation of the day is for today. So we are basically in the southern southwest part of Ontario, Windsor-Essex region. We are very much working in this region, which used to be the automotive center of Canada. We have now transformed the region to automobility hub for Windsor, for Canada. So we have actually doing a lot of regional economic diversification and growth effort with anything related to automobility. We are very much invested in terms of startups, university research activities, college activities in issues related to CASE, connected, autonomous, and with everyone's permission, we change that to secure instead of shared, and electric vehicles. And we are basically one of the largest in the Windsor-Essex, not just the university, but the whole region is actually Canada's largest publicly accessible, has a VR cave, which is open to public for virtual reality issues. So we are the automobility capital, and therefore we are basically trying to attract businesses, develop industry-ready talent, train students at different levels of expertise, and bring innovation and startup environment to Windsor. Actually strengthen it, because there are already a rich number of companies situated in this region. In the SHIELD Center of Excellence, we are very much working on three main pillars. The very conventional one is the innovation and research. We are, of course, a university, so a part of a university. So we are very interested in training our students. We are attracting a lot of industry funding. So these fundings are mostly supported through federal, provincial, supported programs. We have a series of courses that are offered as micro-credentials and micro-certificates on different topics, and our series of micro-credential and micro-certificate courses with relation to cybersecurity will be, start this summer. And we are working with policymakers and standard development bodies to make sure that the knowledge transfer and basically, the level of communication between engineers and policymakers, this line of communication is secure and ongoing. So we are basically started to be officially known in January 2021, and we always emphasize on automobility or automotive cybersecurity, because the cybersecurity is not a new topic. However, automotive cybersecurity with itself brings a long range of challenges and problems that need a closer inspection. So while we are borrowing some of the ideas from the typical IT security, but we are primarily investigating any issues related to embedded system and automobility issues. So now getting to one of the research that we do in the center is on basically IoT. And the motivation that we had for this research is especially with the rise of connectivity, not just with automotive, but within the whole spectrum of devices that people have, the issue of hardware is getting more and more complicated. So when you have a complex electronic system that needs to go through basically a manufacturing and production, then come back as a product to the consumers, it actually has to pass more than a few lines and borders of related to the manufacturing. And manufacturing these days is not a very vertical line. It might have more than a few subcontractors and different entities. Each are kind of assembling different parts, the same as you can imagine a vehicle, that each part, each program, each line of code might come from different entities, assembled on a nice, platform, and then with a ribbon on top, there you go, that's your new vehicle. Among the many, many challenges that the security of these vehicle and, these complex systems have, the idea of the Trojan hardware is making us losing sleep overnight. The reason is that the increased complexity of the hardware is preventing more and more the reliability, assessment of reliability and integrity of the electronic parts that we get. So the talk of today, the rest of today's talk, I'm just going to go through a few high-level examples of what is wrong with hardware these days, and hopefully we can make sure that when we talk about the cybersecurity, we're not going to forget this very, very important aspect. So this is actually not my code. This is another professor from the University of Florida, Dr. Tehranipur, that says the one big threat when it comes to cybersecurity does not have anything to do with the software. Unfortunately, it is the hardware. So there are basically these parts. You buy them on different vendors, assembled, tested in terms of functionality, and then put on different places, all the way from microwaves and consumer electronics to more important, more sensitive end applications, such as public transit and defense, or some of the more high-risk scientific projects. So we'll look at the counterfeit before going and diving into the Trojan hardware. Let's just have a bit of a look at these two samples here. So on the face value, when you look at them, they look almost the same, right? You basically are not able to find any faults. But if you look at the basically the rectangle that is on the upper my right, I think it's a larger black part, there they don't actually look the same. So that means that there is something up there. So these two if we are going through a very fast inspection, a fast visual inspection through them, they actually might not be the same as we intend them to be. Let's look at another example. Here I have the view of two integrated circuits, two ICs, the top and the bottom one. So find the fake. Which one is the fake? You see that there is a slight change on the fonts on these two hardware. Everything else somewhat looks good. The only difference is that there is a dot on the left side of this slide where the M7 is, which is actually shifted lower for the one that is on the lower part. So unless you are very familiar with the real part, even your visual inspector might fail in identifying or finding this, which one is the correct one. And actually the bottom one is the correct one. The dot has to indicate the pin that is numbered 1. Another sample, find this fake. So these two are basically very look-alike. There is a bit of a difference in the naming. The first one has 3 lines, the second one has 2 lines, but in terms of connectivity, in terms of basically everything, they perform well. So if you test this hardware without actually knowing which one is the real one, they do perform the same on the test and verification stage. But in fact, the right one, the one that is on the right side, that's the one that is the accurate and the correct part. The one on the left is a counterfeit. Let's go through a couple of these ones. So on these ones, there is actually, you see the Intel Pentium from the top figure on the left. And then there are a couple of other samples there. So, so that's not bad, but when you zoom in with a very, very good microscope, which is actually the figure on the lower side right, you see that so there is a little bit of problem in terms of the basically issues there. There are black dots all over this IC. So even though it is accurate, it's coming from the manufacturer that is supposed to come, it is a rejected part that is being sold now to industry. Actually, if you look at the top row, the very first one on right, you see the dot, but unless if you decap this part, you won't find it. You might find this through some test and verifications, but let's actually look at another example. This one is again of the same brand. And yeah, there is no big dots in there, so that looks good. But if you pay attention, we see that the logo that is on the bottom right is not typed correctly. It's actually the reverse. Intel is printed in a mirror image. So you need someone to decap this IC, zoom very much into that to be able to read that, to read that line. This IC will pass the verification and functional test, but it's not the part that you want to use anywhere on your devices. We don't know who manufactured it. Another few of these fake ones. These are actually some X-ray versions of the same, seemingly same, the same IC and hardware parts. But as you can see, as soon as you go through the X-ray version, there are subtle changes in how the wires and bonding has taken place. So we cannot be sure which one is the part that was supposed to be sold to us and which one is the part that we actually just found its way through cracks and are now sold. And imagine that usually in these days, in this day and age, because of the supply chain shortage of hardware, The issue of fake and counterpart and Trojan hardware is getting more and more sensitive and basically causing more problems. In a pack of hundreds of these ICs, you might have some good parts, but it seems that these days more and more of these fake parts are finding their way. So by the way, the very one on the top right is the correct part. The other ones are not the correct part. And there was a research that was done by the APMA, cybersecurity group, where they actually inspected close to 100 very tiny, very regular op-amp, which is kind of floating everywhere. They are one of the most common parts. So hundreds of these were decapped, scanned, and investigated very carefully. And of those, only, I guess, 22 were were actually the good parts. The rest of that were fake. So 22 out of 100 for a very common part is alarming. Let's look at another one. This one is not a fake. This one is one that has been used before. And so if we decap it, if we look at the brand, everything looks perfect. But however, when we basically zoom into the pins, we see that there has been a little bit of friction, as if they were trying to remove the glue from this and then reuse it in a new architecture. So this one is not the latest model, the problem that it has, but it is one of the previously used parts that has been installed in a brand new equipment. This one is also another way. So this one, you can see that there is a little bit of difference of discoloration on the top part, where the right side is a bit darker than the left side. And therefore, this would indicate that this device has been probably polished. Again, this is one of the parts that's ordered correctly, but it's not a brand new hardware. And a bunch of other ones. Again, if you look closely, for example, for the second sample, there is a bit of a friction line, kind of showing disturbance on the 6 and 1. The other one also, they have a different variation, different wear and tear that indicate that this hardware has been used probably in whatever the electronic that they were used for maybe 4, 5, 6 years, and now are getting reused. So what I would just want to emphasize is that we are not against recycling of electronic devices if they can. However, if we are buying parts for very sensitive applications, for example, for biomedical applications, for defense, and public transit, we have to actually make sure that the lifetime of our hardware matches our needs. So that's one of the alarming issues. Now I'll just zoom in a little bit more into the hardware Trojan part. So what is hardware Trojan? The hardware Trojans are basically very, very damaging, and I'll just skip over some of the figures to get to more of the samples and examples. So in the hardware, when you buy this hardware, you receive it as a capped version, right? So it might have basically added components inside of it that are at the nanometer dimensions. So you won't even be able to identify or find them through visual inspection, through X-raying, or even recently we found out they don't even have any indication. What this Trojan hardware can do is that they are basically placed there. They are not alive. You are not able to find them through any test or verification that you traditionally do on your hardware. You cannot find them through their side channel signals, but they are there. They are barely alive, and they get basically they come to life whenever they want to destroy or disable a system, leak information, and basically send extra sensitive info that you want. They are very, very hard to catch, and this is actually a war. We say that that exists these days when we think about the integrity of our supply chain. The complexity of the hardware Trojan is very wide and varied. And again, this is again from the taxonomy that is developed by researchers. This is not my work. This is Dr. Tehranipour's work that shows that there are so many variations in the hardware, all the way from a single transistor at 20 nanometer dimensions to maybe a couple of discrete resistors on the PCB board. There are so many effects or payloads that they can actually come up with. They can be always on, but most of them are hidden. They are not active. They don't even come to life if you just randomly try to trigger them. They have their own trigger mechanism. And this is very serious. So whenever we think about the hardware, we should actually think, or basically whenever we think about the security of a system, we have to be alarmed. We have to think about what we are going to do with this Trojan hardware. It's actually not a sci-fi topic. This war, the Trojan War, is already going on. It's a little bit hidden because we haven't heard much about it, but it is one that is going to impact us greatly. We are not going to be able to remove the hardware that easily. We are not going to be able to just repair this easily. It's not repairable. You cannot, basically send a patch and remove it. Once it's there, once you've fabricated the device, it's going to be there for the lifetime of that part. So this is a very sensitive, a very critical issue that anyone that is considering creating systems as complex as an autonomous vehicle has to be very worried about and think about it. Just wanted to, I had actually a video here, but it's not there. I just wanted to bring it into perspective of the device size. So I'm going to show you a little bit, a few more examples of the levels of the Trojan that exist on a board like this. For example, if we focus on one that is figure 1, that is part, you see it as number 1. The zoomed image is on the left side, shows that there is an extra resistor has been added there. So that if you have a program that does a surface scan, you might be safe from that. The second one is the power controller. This one controls the power feeding the whole network. You won't be able to find the Trojan inside just by inspection. It is actually inside and under that protective plastic cap. So you a special measures, a special methodologies to overcome that. Okay, then there are these, the pin counts, which you just by removing, the connections, you might actually come up with a different, routing or operation for your circuit. This is actually the flash memory or the BIOS of the part. It can cause a lot of damage to your system. Again, you might not see the Trojan here. And the largest of the one that is causing sleepless nights for me and my research group is when you have the FPGA core that is having a lot and many components in there. So I just want to actually go to this slide as a and these are open. I couldn't share the latest, graph of Intel processors. So these are publicly available, but a dot, actually a real dot on that colorful image could be your hardware Trojan. Another view of that is, and I think that's the video that we skipped, but I see that it's still there, so I'm going to remove it. I just wanted to bring your attention to this figure. On the right side, you see two transistors. That's the map of a transistor. That's the layout of a transistor that you send to the manufacturer. So even if I look at these two transistors with a microscope, I can kind of see the shapes. That's the CI. That's what I can see through those visual inspections. And on face value, yeah, they're actually good. But if you pay very close attention, you see that the pink, there is the background pink and there is a very little background green that are switched. That is the doping level of the material. That's at the 10 nanometer dimensions. And that's very, very hard to detect because, again, you detect the shape. It's the same shape, but these are not the same devices. And then we insert that 1 to 10 transistors into that millions of transistors within our FPGA board, and it's going to be the perfect storm for the security of the devices. Again, very hard to detect these. These are some of the ways to detect the hardware Trojans, but none of them have the 100% success rate. We are still in the early days of trying to detect, find out, and even discover the new Trojans that are possible to insert. We don't know the whole bunch of them. So what the challenge is that we are basically have to fight with human intelligence, with smart people that know where and how to insert these malicious hardware. They are very quiet. None of our conventional test methods are able to detect and find them. And our conventional ways of evaluating cybersecurity doesn't go as far back as who our vendor is. Where do we do the manufacturing? Do we have a reliable team at the fabrication level? Who are the subcontractors? And those are the issues of the cybersecurity that are usually neglected. So again, they don't need any extra circuit, most of them. Some you can see it on the PCB board. Most of them, you're not able to see them. The ones that are by changing the material composition are even harder to detect. You're not able to find them out. And the modified circuits are basically look very, very like the layer, the one that is supposed to be. So it's very hard to detect. So as a result, and in order to bring a little bit of basically clarity to the research, we are whenever we develop a hardware in our labs, we never go by just saying that, okay, this is good, we're now able to use this method of either encryption or physical or physical unclonable functions or encrypt whatever. We never just as soon as we develop the hardware say, oh, okay, encryption is there, we're safe. We basically have developed and going through this, and we are emphasizing in our center that the red-blue team concept that has been long existed for the software has to be always applied to the hardware. We have to test the hardware from different weakness points, make sure that if we cannot guarantee the Trojan, at least we have a resiliency protocol inserted within that hardware so we know if we are getting attacked, what we are going to do, what is our plan. And therefore, we have a proper way of creating the safety and security within our vehicle, in public transit, in cell phones, and everywhere that we are using the electronics. Well, I'm going to stop here and would, again, thank everyone for allowing me to, giving me your time to talk about the hardware Trojans. The topic is of great interest to us and my research team, and I look forward to hearing your questions.
thank you so much, Mitra. This was a topic, just from looking at the chat, that many of our guests have not really considered, certainly not in the detail that you and your team have. So a few questions to start. One of our guests wonders what the actual results from a Trojan attack have. What are the potential outcomes of such an attack?
It gets very complicated. The payload of a Trojan attack depends on the designer and their level of access to the hardware. So it could be all the way from shutting down the system, your FPGA board basically going dead, to just staying on, but however leaking the information, to disruption if it's a part of, for example, an infrastructure network, to basically causing disruptions in services. So the challenge with the Trojan hardware is that the way that they get active and the way that they, or their payload is not being identified, or is not limited. And there are many, many possibilities. Depends on the malicious persons that is inserting it. So possibilities are endless.
And one of our guests suggests that the results of a Trojan attack in, for example, military infrastructure or biomedical infrastructure could be quite devastating. Any comments on those?
Yes, they are. So I'm not very kind of know what the defense-wise their components. Of course, they would keep it as a secret. But if you realize from time to time, you hear the news that they kind of ground certain equipment or certain jets, and that's where you say, now we now know why they actually are not, flying those anywhere. So yes, it's absolutely very, very critical. The problem is that the Trojan designers are getting better. So back a few years ago, when you had a Trojan hardware, they were basically making noise. And you could measure the noise level of your hardware and find them out. Now they are just inserted at the very basic manufacturing side, where they're just saying, I'm here, but don't want to ignore me. So they basically change the doping of the material, and that's not very easily detectable. For the current research is we are trying to find out how we can detect any existence of the Trojans. And the challenge is that other than the complexity of the Trojans, you have no idea if this is a singular fault that happened for this, for example, for this batch, or is it a Trojan that is acting up? Should I throw the whole purchase or just be worried about this batch that I purchased? So there are at this time, what we are proposing is that make sure that you have basically fault tolerance or resiliency solutions inserted in your hardware. So in case your clock on your FPGA board goes dead, you have a plan for that hardware. And this is basically, I know it increases the cost. It increases the area, but for certain parts, for certain applications, I think it's safe if we pay those costs upfront rather than later.
All right, thank you very much. Another question from one of our guests. I get the feeling we're slowly entering these state-level actors with supply chain hijacking and hardware, Trojan attacks as you've described. How could an organization without this level of tooling or expertise be able to feel confident they're running secure devices?
Unfortunately, at this time, we don't have an organization that is, a national organization. Even I can't come up with names in US or in Canada that are taking care of this. Most that we suggest is that to get in touch with there are certain companies that have expertise, and get in touch with research centers and universities to basically assist you in this thing. Trojan hardware is not on the map for many of the industry partners that we have. They kind of think of it as a afterthought, but we see that it has, as you saw, it has to be taken care of right at the beginning. I don't know, we probably have to start adding a body of government or organization that takes care of that, especially as you can see, we don't have any facility for financial and economical reason, any facility that basically manufactures hardware here. So we always relying on overseas. So the issue is, of course, much complex than one organization or one entity can solve. This needs a national level, wide, a higher up probably level. But for smaller, medium enterprises, get in touch with universities and startups that are basically looking at this issue inclusively.
Thank you. And so you kind of responded to another question one of our guests had is who is the standards body in Canada? For example, the Canadian Standards Association, they are not looking at hardware per se through this lens.
No, at this time, no one is looking at this issue with certainty. The challenges that currently people are dealing with is mostly with mechanics of V2X communication. Okay, how do we make it more efficient? How do we make it faster? So the different parts of cybersecurity have basically standards, but at this time, other than the ISO 21434 that starts to look at the issues of hardware security, we don't have any known organization or known body of standards. So another issue that when I talked about the ISO 21434, they are trying to bring this into perspective, but the problem is that no one knows where the lines are drawn when they want to follow this standard. Is it the job of an OEM? Is it the job of a small and medium size enterprise? So right now, the gray zones are all over this standard.
Absolutely. And amplified likely, we've had a couple guests ask about the current supply chain challenges globally as a result of the pandemic. Do you see expanding opportunities for Trojan attacks as a result of these supply chain issues?
Of course, because some of our even smaller projects, and we are not for-profit organization, right? So we don't have the deadline for selling a product. We have to basically buy right now whatever we find on the market. I can imagine that larger institutions or industry partners that have delivery deadline or component parts or a product deadline, although they have probably better connections, but at this time they're going to buy whatever comes their way. If there is someone on the other side of this manufacturing line sitting, trying to sabotage those products, this seems like a perfect timing for them, unfortunately.
Well, and it just gives new dimensions to the phrase buyer beware. I mean, it in some ways, it seems like an insurmountable problem at the moment. Can you talk about a particularly effective Trojan attack? Like what have the outcomes been of one or two attacks that you know of?
Sure, for sure. So embedded systems are now everywhere, right? From cars to electronic devices, they're almost everywhere. Everywhere on these devices, they have a clock that basically synchronizes the internal operation of that device. So it's like a pulse that needs to be constantly running, and based on that internal clock, that's not the clock that we are used to. It's the internal clock of the device. The operations, the mathematics are performed, and it's like a square pulse. So we were basically last year when we were looking at that, And we were looking and trying to see how we can use this clock because that has to reach almost every node of the device in order to make them operational. So we were looking at that, and we found out that just by visual inspection, and very readily we can find at least 20 ways of disrupting it. Once that clock stops, that embedded system just goes dead. So the whole IC, not just the whole IC, maybe the whole PCB just goes dead. And that if it's, for example, connected to a vehicle that controls the part for the acceleration, that's very important to, that's very, very critical. PLLs and clock frequency generators on hardware are usually being looked at as a way to safeguard hardware. And now we are seeing that no, there is no way out of this. With very minimal changes, you can disrupt this whole thing. And that could, and many of them actually, even we looked at, are used in on critical instruments in hospitals. So if by any issue they get activated, even 5 minutes probably is an issue for that patient that is under that device. If you are driving in a highway and that part all of a sudden gets activated, that Trojan gets activated, then the passenger are in trouble, and there is no time to remove the hardware and solder a new part on that. And just wanted to mention that the Trojans, they don't need to communicate with with the outside world. Some of them do, some of them don't. They're just sitting there, and just randomly, based on what the designer wanted, they just get activated. So they don't need any link of communication. Also, some of them, they really don't need it. They just get, I'm on.
Well, that's extraordinary developments in our world. Many more questions for you, Mitra. Do hardware hackers or Trojan detections have an alert system similar to CVEs?
Trojans, no, unless if you had that resiliency solution integrated in your solution. So the hardware issues and the Trojan hardwares are, unless if they kind of behave very weirdly, so you have an anomaly detector somewhere in your system to flag them out, they really are not that obvious. Again, once they come active, the speed or the payload that they demand is generally so fast that the user doesn't have any time to flag it, to process it, and we don't know. We are trying to basically use methods of intrusion detection or methods of anomaly detection using AIs over the hardware to detect it. But a lot of times, and that's why we're losing sleep, it's not a small problem. The hardware seems okay, and it just does send that message all of a sudden. So if that layer of AI or the anomaly detector wants to detect that, it needs to be ultra fast, ultra efficient, high 100% accuracy type, which people that are are working with those, they know that that's almost impossible. So there are ways. The research is just started, and we are hoping we can come up with solutions. But as of now, there aren't any method for flagging other than detecting the anomalous behavior.
All right, thank you for that. A couple questions about Supermicro. So one, and it's kind of a two-part question, Mitra. First one, was Supermicro for real? And the second question, has there been much of a market shift since the Supermicro incident reports from 2018?
So I didn't get what the question is. They want to know if it's real, or is it
and maybe
more comments.
Maybe it was facetious. Was Supermicro for real? Was one question, and the other one: has there been much of a market shift since the Supermicro incident reports from 2018?
There seems to, but in terms of it is real. But also in terms of shifting the market, some of the, some countries, and especially, for example, let's think about Canada. We don't have that large resources that, for example, China, US, India, or the European Union have to shift all of a sudden. So we are always a little bit behind on the trends and issues that happen. I think that there are other more governments that have the more resources, financial resources, they probably can move in that. But in terms of a Canadian move, haven't seen much waves in that direction. Tiny sounds here and there, not much.
All right, thank you. Another audience question. Do side channel methods show any promise to detect Trojans?
We use the side channel side channel analysis, because attacks can also be done by side channel. We used to use them, and they are effective to some extent, but not all the time. Some of these, methods. So for the side channel attack, you basically need to make sure that you're reaching out all the nodes, and you're basically are able to trigger that Trojan. So when it becomes active, it causes that change in the side channel info, so you can detect it. But the malicious actors are getting smarter. They're basically inserting the Trojan at nodes, on the nodes that are not easily accessible by the traditional methods of side channel analysis. So therefore, more and more the side channel methodology falls short in detecting those Trojans. What we were thinking, as I mentioned, is that try out the clock generators, PLLs, basically, because they have to. However, they are themselves open to attacks, and not all of the nodes within a circuit need that synchronizing clock. But you're absolutely right. There are some effectiveness in the side channel, but not 100%.
All right, thank you. And a question from the audience, Mitra, we were discussing this in the green room. Can you comment on silicon-based hardware root of trust as a solution?
That is something that seems to point out that, as engineers, we are doing our best to come up with technical ways of ensuring that the hardware is secure and the line is, or basically the part is accurate. In the end, there has to be basically a trust basically path from the manufacturing and design all the way to the consumers. And that has to be basically done at the very high level, national and government levels, to make sure that we know where we send our parts, and basically have all the safety measures and security measures basically considered during the manufacturing. So the audience, I agree with you. It's just that haven't seen that even with the shortage of the parts, even with the issues right now with the supply chain, unfortunately haven't seen that much activity on the Canadian side. The others are moving to make sure they are secure, maybe because we're a smaller country with less resources. We don't have it, but I think it's time that we start coming out of our shell and start taking these issues seriously. Not just automotive, agriculture, power, infrastructure, they all can basically get attacked by the Trojan hardware and Trojan software as well.
Indeed. And an interesting perspective on one of our guests who's suggesting, this audience appears to have been, for the most part, unaware of Trojan hardware attacks. And as we discuss it, are we actually giving a view to the criminals for a new avenue of attack, or is it well established among criminal networks that this is a way to disrupt our lives?
They know it already. So it's our effort is that to bring awareness to the users, to the developers, to the scientific community, and just mention that this is not something that you can ignore anymore. So a lot of there are more than a few, actual events that have taken place by the Trojans. And this will, because of our dependency on overseas parts, we have been vulnerable. Trojans have been known since when we had the digital circuits and industry. So 30, 40 years, they know it already. They've been using it already. What is missing in this piece is that we are not talking about it, we are not aware of it, and we are not coming up with solutions with it, which is basically the purpose of today's, that what I wanted to bring into focus is that time is running out. Fixing the hardware is very costly because it can't be done by a patch. The whole system might need to go through an update, a physical update. So take out the parts and place the new ones. And for example, when we are thinking about a truck is a 40-year investment, right? So we have to think about these issues, about this as we are moving more towards fleets, towards AI-driven, cybers, trucks and so on. These are the issues that we cannot ignore anymore.
Well, certainly, Mitra, from the chat, among our guests, they are not going to ignore it from now on. A couple final questions for you, Mitra. Does this mean that hardware redundancy, using completely different hardware manufacturers with different manufacturing processes and suppliers, is that a valid approach to providing some level of protection against a Trojan hardware attack?
There is basically some people and again, this evaluation of the risk management and risk assessment is something that has to be done by the organizations to come up with different solutions. I don't pretend that I can do that for any organization, but yes, there has been suggestions that we buy the same part from different vendors. But the problem is that some of them, they are basically dominated by major manufacturers. And if a company or, when there is a mass production of a part, the manufacturer cannot wait for these smaller entities to deliver the parts. So therefore, they rely on the suppliers that are larger. They have, faster delivery time, lower price. So those are some of the issues that any organizations, when they are from OEMs to medical device, whatever, they have to think about the hardware security, resiliency of the hardware, and insert that in their overall risk mass assessment and risk evaluations.
Indeed, and as some of our guests have noted in the chat, it's such a moving target. And was it only in generation X or Y of hardware that a Trojan was inserted? I mean, how long has this been going on?
Oh, 30 years or more. It's not a new topic. It actually exists and have been, basically active topic. The problem is now more showing up at a higher, magnitude, is because of our moving with basically towards the IoT, having everything connectedness to everything else. And I sometimes joke now, even our pillows are connected to internet. So when at last I saw in a site in a store and say, I don't know why we are doing that. But anyways, the rise of IoT and 5G communication is put the hardware on the spot and basically make or causes these issues to become more sensitive. But it's not a new topic. It was always there.
And that's really fascinating, Mitra, because it's always been there. But for me and many of our guests, this is kind of a new threat vector, and we are well down the path of Internet of Things and 5G installations. What is an appropriate path forward for us? In our last few moments, can you give us some direction, hope on how we can manage this issue?
Well, I think that these solutions are, of course, have to be taken, or we need to, whenever we are looking at the security of a vehicle or security of a system, we have to make sure that we are not ignoring the hardware. We probably need to actually start a national conversation about these issues. They are doing the same damage as a software, a hack. So there are hope. Research is active, but we just probably need to start talking about it more openly, share our ideas and share our solutions together, because the more we know about the different scopes or different issues or different styles of Trojan, the more informed we are, we can make better decisions. For some reason, issues related to hardware are always dropped out of the security and cybersecurity discussions. So I think that it's time for hardware designers to get educated about cyber, and cyber specialists to get educated about the hardware, and we have a more open discussion about these issues.
Well, thank you so much, Mitra. That was a fascinating talk. You've certainly put hardware security back on the top of the list for certainly many of our guests, and given us lots of issues to discuss and explore. Thank you so much for your presentation and your participation in the summit today.
Thank you very much for having me, and I look forward to future discussions about hardware with anyone who's interested.